Okay, today we're going to talk about very brief introduction to organic chemistry. This isn't specifically with Unit 1, but this is going to get us ready for some of the things we're going to talk about in Unit 2 and Unit 3. And you don't have to know a lot of organic chemistry, but you do have to be somewhat familiar with the names, a few of the names. So if someone says that we're dealing with ethyl alcohol, you have to understand what that entails, because it's going to give you a little bit different properties than as opposed to some other organic compound. So again, we don't have to know very much, but we do have to know a little bit of vocabulary. So no, not really any way around it. You're going to have to memorize a few of these prefixes. Don't worry about any of the other things you see here, but here are the prefixes. Now, I'll name a few of these, but you can read these as easily as I can. Meth, eth, prop, but, so forth. You can use those in a bunch of different ways. So that prefix is going to go with a suffix. In this case, it looks like all of our suffixes are anes. Don't you look at this yet. But so one of our suffixes is ane. But we have a bunch of other suffixes we're going to talk about. But how do you know which of these prefixes to use? You just count up the carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you have 9 carbons, there's your prefix. If you have 1, 2, 3, 4, there's your prefix. But is the actual prefix. Now, we'll talk about some people have some common names. And also, some folks use something to connect the prefix and suffix just to make it kind of sound better, I guess. So we'll talk a little bit about that. But if you have the prefix and you have the suffix, you're going to know everything you need for AP chemistry. Now, when you go and take organic chemistry, either with Mrs. Riefner at our school or when you take it in college, you'll get a lot more expanded knowledge for sure. Okay. This last column here, the one that I X'd out, when you take one of these sets, this is actually a molecule. It's called ethane. And we'll throw this in here. This is the Lewis dot structure of ethane, and it has, again, 2 carbons, 1, 2, and it has 1, 2, 3, 4, 5, 6. Here's 3, and here's 3 for a total of 6, and that's a compound, and it is a molecule. Well, if you take one of these hydrogens off, you can attach other things to it. And so now, let's give it a different color. This part used to be ethane. Well, now it's an ethyl group, and it's going to be attached to something else. We don't know what it's going to be attached to because we haven't gotten that far yet. So it'd be ethyl and then some other name, ethyl alcohol, ethyl chloride, something, ethyl acetate. But we'll see where that takes us. Now, can you go past 10 carbons? Absolutely. Are we going to go past 10 carbons? No. Okay, so another thing we can talk about, and we'll do this a little bit more in class, is we can talk about isomers. What the heck is an isomer? I think you learned this last year, that vocab, but an isomer is the same number of atoms, just a different configuration of the atom. So it looks like we have, if I count these up right, 4 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. So you could have this configuration, and that's called butane. For us, it's called butane. It has a prefix. We don't know why it has the suffix ane yet. And this, we're not going to get into why it's called isobutane, or these. There's a lot of other namings that you can get in organic chemistry. We're not going to get that far, but it still has 1, 2, 3, 4 carbons, and I'm not going to put a check mark with all the hydrogens, but if you count those up, it equals 10. But certainly this structure does not look like that structure. So if you have a different arrangement of atoms, that's an isomer, but the same number of atoms. Okay, so here's 3 of our prefixes. So if you change the number of hydrogens that get attached to the carbons, then it could be an ane, it could be an ene, or it could be an ine. And you could memorize that little mathematical formula. So let's just do one of these. We'll do one of these ines. So if I go and say I have 3 carbons, that's N. The hydrogen would have to be 2N, which is 2 times 3 is 6, minus 2 is 4. So that would be the arrangement there. We don't need to keep that up there. But you can also think about it this way. If everything is single bonded, now hydrogens have to always be single bonded, but carbons can have single bonds right there. They could have double bonds right there, or they could have triple bonds right there. And if you have a molecule that has all single bonds, it's an ane. If there's a double bond somewhere in the molecule between carbons, then it's an ene. And then if there's a triple bond somewhere, it's an ine. Can you have combinations of those? Yes. Can you have multiple double bonds or multiple triple bonds or a combination? Yes. Are we going to do that in this class? No. So it's going to be very simple for us. If it contains a double bond, it's an ene. If it contains a triple bond, it's an ine. And if it has all singles, it's anes. So here again are some Lewis dot structures of an ane, an ene, and an ine. And which of these would it be? I'm counting 2 carbons. So the prefix would be eth, and then the suffix would be ane here, ene here, or ine there. Disregard this one for a second. This is a completely different type of hydrocarbon. By the way, these are all called hydrocarbons because they have hydrogen and carbon. No other elements. Okay, so now if we start to add other elements to the mix, then it's not a hydrocarbon anymore. It's these different types of molecules. And they have different suffixes. This one isn't really a suffix, that's just a name. Okay, so let's look at a couple of these. Eth and all. So eth means 2 carbons, and then all means it's an alcohol, and we're going to get to this in the next slide here. But what would this look like? First of all, if it was ethane, and we can always start with the hydrocarbon and then make it into whatever we want it to, in this case alcohol. So here is ethane, and remember I said if you get rid of one of the hydrogens, then you can attach something to it. In this case, we're going to make it an alcohol. And we don't know why yet. We're going to learn this in a second, but this would make it an alcohol. So it still has 2 carbons, so it's still eth. But because it ends in that instead of hydrogen, by the way, I have it end here. This OH could be in any of these other spots. And if you take organic chemistry, you'll have a specific naming that could happen depending on its spot. Although this one's not going to be quite the same case. We're not going to get into all those details. But here are your, again, all of your suffixes. And we're going to talk about how would you get a ketone versus an alcohol. So let's look at what those would entail. So let's go to the one we just did, alcohol. Again, ends in all. By the way, many of these have common names or a variation to their name. Why? Because that's just how it is. And the way I think, where I'm programming you to use is the prefix meth and the suffix all, methanol. Wait a minute, Mr. McNally, isn't it methol? It should be methyl, but that doesn't sound right. So people use this connector between the prefix and suffix methanol. If you said it this way, that's also acceptable. Why is it acceptable? Because organic chemists out there understand what the molecule is. If you say methyl, that's the group, and then alcohol. So that would work. And so remember that you have to have all the hydrogens. By the way, they don't mention any of the hydrogens in here. It's just accepted that these would all be hydrogens. Because there's not a lot of room to write all those in there. But you have your carbon and hydrogen group, and then you have your functional group, in this case, an O bonded to an H. That makes it an alcohol. I'm going to erase those so we can kind of look at another one now. So then let's go to a ketone. Actually, let's go to a ketone. So ketone has to end in -one. So again, you would count your carbons. In this case, it looked like we had 3, so prop, and then has to end in -one. And they do have that connector, that "an", so propanone. On the test, if you said propone, I'd give you credit because you have the prefix and suffix, but really it should be propanone. And why is it a ketone? What do you have to have for this to occur? Well, it looks like somewhere in the middle of the molecule, not at the end, you need a double bond to an oxygen. And we'll talk a lot more about these in class, where I can get molecule kits out that you guys used, I think you used last year. So let me erase that one. And we'll talk about one more of these. We'll do carboxylic acid. So instead of saying, hey, it's pro-carboxylic acid, no one does that. They use this at the end. Oic would be a suffix, and then they attach the word acid to it. So what would that look like? It would have, by the way, a lot of people use this to mention all the hydrogens and carbons that would be attached. R means, again, it could be 3 carbons with a bunch of hydrogens. It could be 12 carbons with a bunch of hydrogens, whatever. But a bunch of carbons and hydrogens attached to a COOH. That's a carboxylic acid group. And it looks like, in this case, we have 1, 2 carbons, so eth. And then it ends, let me erase that, in a COOH group, which is a carboxylic acid group. So it has to end in oic acid. Well, it turns out that lots of folks also call it acetic acid. So you may have memorized acetic acid from last year, and that's acetic acid. This H in the front kind of designates that's an acid. And this is how inorganic chemists would show this acid. Well, organic chemists show the same molecule, but they show it this way. So some people write it this way: CH3, that's part, and then the COOH. Turns out they're exactly the same molecule. This H in the front designates it's an acid, and then that COOH at the end designates it's an acid. Here's your organic chemistry way, and here's your inorganic chemistry way. Same exact molecule. It's not to try to make it more confusing for you, it's just that they're kind of coming from different points of view. Okay, so I think I mentioned this. We had a slide previously that had something called Aromatic Ring. You can do lots and lots and lots of things with these. We are not doing lots and lots of things. This is as far as we're going to go. Here's a molecule that has a common name called benzene. Benzene has 6 carbons and 6 hydrogens. For this to work out, that's how you would draw it. The problem is that takes a lot of work to draw. So organic chemists don't like to draw all that out because sometimes there's multiple of these rings in a molecule. So they shorten it as much as they can. And that to an organic chemist are the same thing. What's that circle? It's a double bond to a single, to a double, to a single, to a double, to a single. What that really is we'll talk more about this as we go through the year, but that's a resonance. It resonates between the double being in that spot and the single being in that spot. Goes back and forth between those two. And so they just kind of complete the look with that circle. So if you see a structure like that, that's a benzene ring, okay? Kind of just introducing that. We're not going to do too much with that. You don't have to know any of these, but I just wanted to show you that you can find these. By the way, that's a pain reliever. That's a pain reliever. That's not a pain reliever, but that'll give you the flavor of vanilla, or the smell of vanilla too. Okay, we mentioned isomers, but we didn't mention, you're not going to have to memorize this, but there's different types of isomers. But anyhow, if it has the same number of atoms, but different configurations of those atoms, it's an isomer. So, I think if you counted up those carbons, you'd find there's 5 carbons. 1, 2, 3, 4, 5. So pent. And then they're all single bonded to each other, so that's an ane. But there's different ways you could draw it. So we're not getting into why it's called those. Here's a different type of, now we have some auctions we're dealing with. So it's very important, by the way, to not ever write the molecule that way. Why? Because you don't know if it's ethanol with an OH group at the end, or if it's an ether. And ethers have hydrocarbons on either side of a single bonded auction. So this method will never be allowed for you to write, because again, you can't tell the difference between what type of molecule it is. And these two types of molecules will have very, 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 very different properties. we do have to know a tiny bit about these optical isomers. Cis and trans. And if you look, the hydrogens are on one side, and these hydrocarbons, in this case, we have bute because 1, 2, 3, 4, but it doesn't always have to be bute. It can be other combinations of carbons. But anyhow, hydrocarbons on one side and just hydrogens on another side. That's the definition of cis. If you have kind of a catty corner arrangement, that's trans. And that's about all we're going to talk about in this class with those. In organic chemistry, either with Mrs. Rufner or in college, you'll go a lot more detail, and also in biochemistry, you'll go more detail with that. But they can have very, 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 very different properties, as you can see here. So those are optical isomers. So the hydrogen is there compared to the other one. It's flipped. And I think that might be it. So that's, again, very, very, very brief introduction to organic chemistry.